Hello, my name is Jeffrey McKelvey, and this is my Lab 4 Oscillations video presentation. During this lab, the purpose was to use the fundamental principles, in this case, the energy principle and Newton's second law, and position data extracted from a video clip of a mass string system in Tracker to make an oscillating model and then determine the period from the x and y period and determine if the energy principle had been conserved. And my result was that yes, the energy principle was conserved in the model that I created using Python. In order to properly understand the physics used in this lab, one needs to properly understand two important principles, Newton's second law and the energy principle. Now, energy is equal to potential energy plus the kinetic energy, which means that the change in energy is equal to the change in potential energy, which is equal to the change in kinetic energy. And the change in energy is equal to work. Now, work is equal to force times distance, and force is equal to mass times acceleration, when acceleration is the change in velocity over the change in time. Now we can break this down to get final velocity is equal to initial velocity plus the net force divided by the mass times the change in time. Now we also know that the initial potential energy plus the initial kinetic energy is equal to the final kinetic energy plus the final potential energy. And then we use the following equations to calculate said energies. The kinetic energy can be found by multiplying 1/2 by the mass of the object by its velocity squared. The potential energy of the string can be found by multiplying 1/2 by the spring's stiffness, can be multiplied by the S, or the variation from the original length of the spring. And then finally, gravitational potential energy can be found by multiplying the gravitational constant on Earth, 9.8, with negative 9.8 by the mass of the object. And finally, the string force can be found by multiplying the stiffness of the spring by the deviation of the spring's length from its original length. Here is the code that I used to create the model, and in order to compare both the observed and the computer-made model. Here we have my initial vector, which was the original velocity of 0, and the initial ball position, which was at negative 0.104, negative 0.640. And this is where we read in the spring mass data, or the data that was collected from Tracker. And this is our delta T of 1 over 210. The spring stiffness was found to be 6.83 with an original length of 0.123. And here we calculate exactly how far it is from the final length of the spring using the ball pause minus the spring position. Here we find K, or the kinetic energy, and then the gravitational potential energy and the spring potential energy. And this is where it is constantly updated while T is less than 9.212, which is exactly the final length of the video that we use. And this is how it is updated. So K initial is used as K, and then K final is later found by using the updated K, which is the final minus the new, which gives us our change in kinetic energy. Here we have simply inserted the force of gravity, force of spring, then the net force, and the ball velocity and the ball position as they are updated. The ball velocity, this is the final velocity that you see here. This is the velocity from the past running of the code, plus the F net divided by the mass ball by delta t. Here we explain the change in length and the positioning of our arrows, which one we'll later see. And this is where we graph our final conclusions of what exactly is drawn from the running of the module. And as we can see here, the red ball representing the mass that I created, and the blue ball representing the mass created by by the code. And here we can see the revolutions of the model ball. And as you can see, the total of all three ends up being 0, with yellow being the final total sum of the energies. In conclusion, I found the energy principle to have been conserved by observing the graph displaying all of the energies measured and their total remained 0 throughout the video. Thank you for listening.